Questions on the homework? Questions going once? Going twice? Remember, as always, you should be checking your answers, right? You can have it all done, but we only get 2 out of 3 points if we didn't check our answers and we have mistakes on there. Okay. Today, we're not adding too much to this. We're not adding new operations. We're not adding anything like that. What we're adding is something called special cases. So most equations we have solved so far only have one solution. In fact, all the things we've done had one solution, except for if I took the square root of both sides. It had 2 solutions, that are plus or minuses. However, there are 2 special cases. You can have no solutions, so nothing works. And you can have infinite solutions, which means whatever I plug in will work. Let's see what those cases look like. So, one solution. It'll look exactly like we've done before. We come up with x equals some number. Okay, so that's what one solution should look like. Yeah, you got it? So we're going to distribute this 3. Hey guys, take the time to draw your arrows. 3 goes to the 2. 3 times 2 is 6x. Plus 3 times 7, 3 times 9, I can do, is 27, equals negative 5 minus 2x. Now remember our rule. If I have variables on both sides, I want to move all the variables to one side. That's my first step. I want this 6x to stay here, which means I need to get rid of this negative 2x on this side. How do I get rid of a negative 2x? Not divide. Plus 2x. We're going to add 2x. Remember, when we're moving something, we want to get rid of it, so I need to add 2x to both sides because I want this gone. Negative 2x plus 2x, that's gone, but the repercussion is I have to do it on this side as well. Now make sure you line up your plus 2x under your 6x. I guess I can draw my line to make sure I'm going on both sides, so we did. So we're going to say 6x plus 2x equals 8x plus 27 equals a negative 5. So as always, simplify first. Make sure you have all the x's or one variable on one side, and then we solve it like normal. So now we're going to go ahead and subtract 27 from both sides, because we always do our addition and subtraction first once we have all our variables on the same side. 27 minus 27, that's gone. We're going to have 8x equals negative 5 minus 27. That should be a negative 32. And then we divide by 8, right? We'll divide both sides by the old ocho.
No way.
And we come out with, what's no way?
What's the answer? Is the answer negative 6?
Negative
What?
4.
It should be negative 4.
I got negative 32.
You forgot to divide by 8.
No, Christian said the answer would be negative 6. I knew he was wrong.
Oh, okay. So we have negative 4. I think you just forgot to divide by 8. We divide both sides by 8, and we have x equals a negative 4. Okay, that's one solution. What's our one solution? It is x equals a negative 4. All right, the next one's going to be no solutions. Now remember, when you are solving for one of these, the first thing you need to do is simplify your sides before you do anything else. So we need to distribute. Not only do we need to distribute, we need to realize that we have a 7x minus a 3x on one side. Remember, you must simplify first. That means combine like terms. We only do it on the left and right, the same side. When we're simplify, you stay. That's why we draw that line and say, I only can do stuff on this side and this side to simplify. So I have 7x minus 3x, which equals 4x. So we're going to have 4x, and we still have that minus 9, correct. Now we're going to distribute that 4 to everything. I'll put both my arrows to make sure I'm multiplying by both. 4 times x is just 4x. 4 times 3 is 12.
Should we just add the 1 to the 12 now?
Sure, you could if you want to. If you're like, okay, that's 12 plus 1 is just 13. I'm going to do that in 2 steps. I'm going to realize that these are like terms. And so now we have 4x minus 9 equals 4x plus 13. Now we have to move the x's to one side, right? So let's say I'm going to keep this 4x here. I'm going to keep this left side 4x. How do I get rid of this 4x on the right side? I'm going to subtract 4x. So I'm going to subtract 4x so this one cancels out. But remember, if I subtract 4x on one side, I have to subtract 4x from the other side. What's 4x minus 4x? Zero. Zero. The x is dropped out, and we're left with just the negative 9 equals 13.
But now we have to
No, we have nothing to solve for. This is it. We're done. We just have to use our big brains right now.
Come on, Gumbo.
This is the only question I have for you right now. Do we have x's left?
No.
The x is dropped out. Now, here's my next question. Does negative 9 equal 13? This is false.
What does that even mean? Is it a positive? No, it's negative 9.
It's false, and so we have no solutions.
I'm so confused. So it's like unsolvable? Yes.
No, Campbell.
Stop. He's asking a question. I think it's fair to ask the question, don't you think?
Can you like divide it and get a decimal?
No, you cannot divide it to get a decimal because this just says negative 9 equals 13. This means whatever I plug in for x, if I plugged a 5 in for x, I'd come up with negative 9 equals 13. This is saying no matter what I plug in for x, I'm going to get out negative 9 equals 13 because my x is canceled out, right? So your x's are useless. Whatever you plug in, you're going to end up with negative 9 equals 13, which is a false statement. So if you come out, you drop out your x's had no influence on the problem. We just have negative 9 equals 13, which is false, which means there's no solutions. Nothing will work. There's no number you can plug in for x that would make this work. Every number you plug in would be not negative 9 equals 13. It does not work. It's no solutions.
Every single number.
Every single number. You could try any number that we know, plug it in there, and you'll get out negative 9. Doesn't matter. Try it. I'm not going to do it right now because we're running short on time from the first one, but I'm telling you, no matter what number you plug in for these x's, negative numbers, positive numbers, it will always come out to negative 9 equals 13, which is a false statement. Okay, let's see what happens if it's an infinite solution. Same idea is going to happen. Our x is going to have no influence on the problem. So we're going to distribute this negative 2 to everything. So I have negative 2 times a 3, which gives me a negative 6x.
Wait, what are the symbols?
I have a negative 2 times a negative 5. This is where I think at least half of you get this wrong. A positive 10, right?
Doesn't we change it to addition or addition?
We change it to an addition sign because it's negative 2 times a negative 5, which makes it a positive 10. So it's plus 10 equals, I'm going to notice that we do have 2x and negative 8x.
6x.
Not 6x, but
Negative 6x.
negative 6x. Because the negative's bigger. Remember, you can plug this in your calculator, right? We can do 2 minus 8, and that should come out to a negative 6x plus 10. Now, can we stop here for a second?
I got it.
You actually know the solution to this right now without doing any work.
Oh.
Hang on. Do we notice something about the left-hand side and the right-hand side?
So it's infinite. It's going to be 10 equals 6.
So whatever I plug in here, as long as I plug the same thing in here, it's going to be equal, right? So I can plug 2's in both of them, 3's in both of them. Anything will work. So right now, we could say, since these are the same, that's why we're going to have all solutions, or it's going to be infinite solutions. Everything works. Now, let's say you didn't catch that, because sometimes you won't catch it. We'll just be solving. Let's say I didn't realize that's the same.
What if you distribute wrong?
Then you have the answer wrong, and then we lose all the points. Okay. Now, let's say I didn't catch that they were the same, so it's all solutions, okay? So let's go in our time machine and go, blah, 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 blah. I didn't catch that. That means I try to get all my x's on one side, right? I want to keep that negative 6x here. How do I get rid of the negative 6x on the other side?
Positive 6x.
I'm going to add 6x to both sides.
6x is such a...
Wait, if we
Stop.
If we add 6x to both sides, then we're left with 10.
10 equals 10, like
Stop, Campbell. Campbell. Do you feel good about the interaction? Okay, so we have 10 equals 10. Is that true or is that false?
It's true.
That's a true statement. That's true, so it's going to be infinite solutions.
Are you going to diagnose the solution?
Yes.
Like, are we going to have to, like, at the bottom write no solution, one solution, or infinite solution?
We will on sections of the test. So on sections of the test, I'll say this is our special section. State whether it's one solution, all solutions, or no solutions. So we don't have to spend a whole bunch of time on the whole test doing this. But in the future, when you get to like algebra, these are just going to be mixed in. Okay? You're just going to have a test, and all of a sudden you have to be like, oh, it means no solutions, and you're going to have to go write that. Are we good on that? Does that make sense? So we didn't do anything different. We just solved like normal. It's just sometimes our variable will cancel out, in which case it either means it's no solutions if it's a false statement, or it's all solutions if it's a true statement, which means we need to take our time and solve these correctly, because if you didn't solve it correctly and you did it wrong and you said it's one solution, that's 2 points off because you did it wrong and you came to the wrong conclusion. So we can have 2 points off if we just don't take our time. What time do we're out here at 9:55. Let's do a few of these problems. All right, let's look at number 1. Nice. It's always good when to start out, right? All right. Number 1. Is my left-hand side simplified?
Yes.
Yes, it is. So we just know it's going to be 5x minus 3. Is my left side simplified?
No.
No. What's the first thing I'm going to do on the right-hand side?
Multiply 3 in both.
In both of these things, right? So I'm going to have 3 times 2, which is 6x. 3 times a negative 1 is a negative 3 minus x. Is my right-hand side simplified?
Yeah. Wait.
No. There's
1x.
Like terms? There are 2 terms that are alike. We have a 6x and we have a negative x. What happens when I have 6x minus, it's not negative 5x,
5x.
just 5x. Because I have 6 x's, I'm taking 1 away. We're going to have 5 x's here. And we still have the minus 3. And the left-hand side is 5x minus 3. What is our end answer just looking at it right now?
Infinite solution.
It should be infinite solutions because this is the same. It is cool because, hey, but let's say I didn't recognize this. I didn't recognize it was the same, so I kept going. Which means I wanted to get all my x's on the one side, right?
Yeah, it's negative 3.
Which means I need to subtract 5 from both sides. Shh. I like that we see this, but we should say I didn't see it. So let's keep solving it. So if I want to get rid of a positive 5, I'm going to subtract 5x from both sides.
What are the symbols? Yeah, you need to inspect it.
Now give me 1 second. All right, so is this true or false? Negative 3 equals negative 3, true or false?
True.
True. So either one of these mean that we have infinite solutions.
I got negative 3 equals negative 3.1.
Well, I have all the work up here.
Come on, Campbell. I think I just added them.
Take your time and do those. Okay, for symbols. I did forget to talk about the symbols, didn't I? If there is no solution that will make the equation true, instead of writing no solution, you can put a circle with a little line through it. Are we good with that? Did we take that note? No solution means we can put a circle with a line through it.
Yes, sir.
For infinite or all solutions, we're going to put the symbol for infinity, which is that like sideways 8. That is our symbol for infinite.
Just write. No, just like carry paper sideways and write 8.
There you go. Campbell, you got all that stuff down? Nope. Good work. Good work.
Write your symbols down.
All right. So real quick, so instead of putting infinite solutions, I could have also written the infant. Either one of those I'll accept as an answer. Okay. Let's look at number 2. Number 2.
They're both simplified.
Hey, Sean said something great. He said they're both simplified, so that means we just got to get all of our variables on one side. Let's say I want to keep the 2n on this side. What do I have to do to the 9n over here? We're going to subtract 9n from both sides. So I'm going to subtract 9n from both sides. 2n minus 9n is a negative 7n. Minus 5 equals 37. Hey, guys, did my n's cancel out?
No.
So that probably means we have one solution, right? Okay. Now I'm going to add 5. You guys okay with me adding 5 to both sides?
Yeah.
All right, let's add 5 to both sides.
42 7.
So we're going to have, make sure it's negative 7n, right? Negative 7n
Equal 42.
equals 42. We will divide both sides by a negative 7.
It equals 6. Equals negative?
Negative.
Yeah.
Yes. N equals a negative 6.
One solution.
So if I said, is this one solutions, no solutions, or all solutions, what would you say?
One solution.
One solution.
AKA true.
AKA one solution.
Sprained my arm and I've been running a lot and it's starting to hurt again.
Okay.
Do you think I can take a little break?
You can. But we're going to. All right, guys, I would like you to do 3 and 4. You're doing 3 and 4. Show me that you know how to do this.